warm welcome to EDUHUNT IIT and NEET Foundation classes. Dear students, in this video we are going to learn the important factors which are governing the formation of ionic bond. Okay, ionic bond, in the previous video class we discussed what is ionic bond and how the atoms are converting themselves into ions and how the ionic bond is forming. In the previous class I have explained you. In this particular class, what are the factors that are favorable for the formation of ionic bond we are going to discuss. See, with these factors you can solve certain questions like which type of substances are more ionic, which substances are less ionic, okay, which is more stable, which is less stable, which is more reactive, which is less reactive. Such kind of questions you can easily attempt. So all of you please try to focus on these 3 or 4 important points, okay, which are the factors that are responsible for the stability of ionic compounds as well as the conditions favorable for the formation of ionic bonds. Okay, dear students, shall we start? Right. We are going to consider the important factors that are favorable for the formation of ionic bond. Okay. So, our topic is conditions favorable for the formation of ionic bond or ionic compounds. I will keep the heading in this way, ionic compounds. Okay. So, what's the topic? Conditions. We are just simply discussing the conditions that are favorable for the formation of ionic compounds. Dear students, please try to recollect that ionic bond is going to be formed between 2 oppositely charged ions, isn't it? Definitely the ionic bond is going to be formed in between 2 oppositely charged ions. What are those 2 ions? One is a positively charged ion, which we call it as the cation, and the other one is a negatively charged ion, which we call it as an anion, right? So if we can write the favorable conditions for the formation of a cation and the favorable conditions for the formation of anion, they themselves becomes the conditions favorable for the formation of ionic compounds or ionic bonds. Okay. So before exactly going to this ionic compound formation, first of all in 2 parts we are discussing. First thing what we are discussing is the conditions favorable for the formation of cations, right? So let us start. What is the first one? Conditions favorable for the formation of cations or a positively charged ions. Conditions favorable for the formation of cations. So these conditions we are going to discuss. Okay. So in the first subheading we are going to learn the conditions favorable for the formation of cations. Okay. In the second thing we are going to learn the conditions favorable for the formation of anion. Okay. Now let us consider this. The conditions favorable for the formation of cation, the first condition that we are going to consider is size of the atom. Please observe, this is the first condition, size of the atom. See, simply for the cation to form, the atom should be with larger size. Okay. Why? Because atom, if it is having larger size, then the distance from the nucleus to the valence electron will be more. So the nuclear attraction on that valence electron is less, so that we can remove the electron easily. That means the cation is going to be formed easily. So simply what we can say, larger the size of an atom, more easily the cation is going to be formed. Okay. So larger the size of an atom, more easily the cation is going to be formed. Please observe, this is our first condition. Okay, larger the size of the atom, more easily the cation is going to be formed, right? So for this one, let us consider the example of the 1A group elements, alkali metals. Okay, so if you consider the alkali metals, I'll explain you here. Alkali metals, usually the lithium, sodium, potassium, rubidium, cesium and francium. Francium, you all know, it is a radioactive element whose chemistry is less known or less studied. Okay, so we are confined to lithium, sodium, potassium, rubidium and cesium, right? So in this particular group, the 1A group of elements, if you consider, you know this point that as we move from top to the bottom of a group, the size of an atom is going to be increased. So as we move from top to the bottom, what happens? The atomic size increases. Atomic size increases. That means what? The size of the cesium is larger than rubidium. Rubidium size is larger than potassium. Potassium size is larger than sodium, and sodium size is larger than lithium. Okay. Now what is our point? Larger the size, more easily the cation is going to be formed. That means if you write the size order, cesium is larger in size than rubidium, than potassium. Potassium is larger in size than sodium. Sodium is larger in size than lithium, right? So this is the size order. So these atoms, after losing one electron, they become unipositively charged cations. The ease of formation of the cation is in this particular order only. Understood? Because cesium is having larger size, cesium can form the cation easily. So ease of formation is in this order only. Cs plus, okay, is easily be formed. Then Rb plus, and Rb plus is easily formed than K plus, then Na plus, then Li plus. So our point is, larger the size of the atom, more easily the cation is going to be formed. Cesium size is larger, so cesium plus ion is easily formed. Whereas lithium size is smaller, so lithium plus ion is formed with difficulty. So I hope all are able to understand the first condition. What is that? Size of the atom. Simply, larger the size, more easily the cation is going to be formed. This is our first condition, right? Let us move to the second favorable condition for the formation of cation. See, the second condition is low ionization potential. Low ionization potential. So you all know that ionization potential is the minimum amount of energy required to remove an electron from the outermost orbit of a neutral gaseous atom. I repeat, what is ionization energy? It is the minimum amount of energy required to remove an electron from the outermost orbit of a neutral gaseous atom, which we call it as the ionization energy. See, the ionization energy value, if it is low, So you can say the condition like this: low ionization energy. This is the second condition, right? So lower the ionization energy, you can definitely say the cation is going to be formed easily. Understood? It is the minimum energy required to remove an electron with which the cation is going to be formed. If the ionization energy is less, means what? We are straight away saying that the cation is going to be formed very easily, right? See, among all the elements which are having lower ionization potential are again the 1A group elements. Okay, so in 1A group elements, if you consider cesium, because of its larger size, it will be having the lower ionization potential. So cesium can lose the electrons very easily. And dear students, please, I am mentioning here a point. That is the reason why this cesium, the rubidium, such kind of elements are more used in voltaic cells or photochemical cells are there, no? Panels, photoelectric panels, etc. In making such panels, these elements are more used. What is the reason? Because their ionization potential is less. Okay, so now if we are considering our particular point, low ionization energy. So lower the ionization energy, more easily the cation is going to be formed. Lower ionization energy implies more easily the cation is going to be formed. Simple. So lower the ionization energy, more easily the cation is going to be formed. So if you consider again the 1A group elements, lithium, sodium, potassium, rubidium, cesium, please observe, you all know this point. So you all know that the cesium is having the low ionization energy. So the ionization energy values, if you consider, cesium is having low ionization energy among all the 5 1A group elements. So cesium plus cation is formed easily. So ionization energy values from top to bottom, IE. Please observe, IE means what? Ionization energy. IE value is decreasing. From top to bottom, IE value is decreasing. So cesium plus ion is more easily formed than Rb plus, than K plus, than Na plus and Li plus. Okay. So therefore, I am writing here, therefore ease of formation of cation, it will be Cs plus is greater than Rb plus, then K plus, then Na plus, then Li plus, dear students. So please observe, this is our ease of formation. So here what is the condition we have considered? We considered that ionization energy is the favorable condition for the formation of cation, and that ionization energy should be low. Lower the ionization energy of the given atom, more easily the cation is going to be formed. Got my point? So this is our second favorable condition. What is the first one? Larger atomic size, and second one is what? Low ionization energy. Up to this 2 points, it is clear now? All are able to follow, right? Shall we move to the third point? Right, very good. See, now the third favorable condition for the formation of cation is smaller the charge, or smaller charge, simply smaller charge or lower charge, you can say, you can write simply as lower charge. So lower the charge, more easily the cation is going to be formed. That particular cation is going to be formed. For example sake, you can simply say, if you consider 3 respective cations, let us suppose a unipositive sodium ion, Na plus, right? A dipositive magnesium ion, Mg plus 2, and a tripositive aluminum ion, Al3 plus. Please observe, dear students, among these 3 ions, out of these 3 ions, sodium is having only 1 unit of positive charge and magnesium is having 2 units of positive charge, whereas the aluminum is having 3 units of positive charge. That means what? If aluminum cation, aluminum positively charged ion has to be formed, aluminum should lose 3 electrons. From the aluminum, if we take away 3 electrons, then only aluminum is going to convert into Al3 plus ion, right? So for Al3 plus ion to be obtained, the number of electrons that are to be removed are 3. How many electrons need to be removed there? Definitely 3 electrons are to be removed, right? Whereas if you consider magnesium, for the formation of Mg2 plus ion, it has to lose 2 electrons, right? It has to lose how many electrons? 2 electrons. So Mg, if it want to become Mg plus 2 ion, definitely it has to lose these 2 electrons. Those 2 electrons it has to lose. Whereas for the sodium, if you take sodium to become Na plus ion, how many electrons it has to lose now? Only this particular electron. 1 electron it has to lose. So our point is, aluminum tripositive ion to be formed, it has to lose 3 electrons. Magnesium dipositive ion formation requires the loss of 2 electrons, whereas for sodium it needs the removal of 1 electron. Dear students, think on your own that is it easy to remove an electron from a neutral atom, is one particular electron, or it is easy to remove 3 electrons from a neutral atom? Definitely, right, definitely it is easy to remove 1 electron from a neutral atom than to remove these 2 and 3 electrons, because after 1 electron removal, the ion, a unipositive ion is going to be formed. That means the influence of nucleus is more. Okay, with that higher pull of the nucleus, if you want to remove further more electrons, what is the thing you need? You need energy. You have to spend more amount of energy, then only you can remove the remaining electrons. So always it is very easy to remove 1 electron than more number of electrons. That is the reason why the ease of formation of Na plus is very easy than Mg2 plus than Al3 plus. Got it? So this is our third condition. What is our third condition? Lower the charge on the cation, more easily that particular cation is going to be formed, right? Higher the charge on the cation, definitely it consumes lot of energy and it becomes very difficult for its formation. Okay, so this is our third factor for the formation of cation. Hope you have understand this. Next, let us move to the fourth factor and the last factor for the formation of the cation. Okay, the fourth factor is cations with inert gas configuration. Cations with inert gas configuration are formed more easily than cations with pseudo inert gas configuration. Pseudo inert gas configuration, right? So what is our fourth factor? The fourth factor says that cations with inert gas configuration are going to be formed very easily than the cations with pseudo inert gas configuration. So to understand this, we need to have an idea that what is an inert gas configuration. This thing is clear, you already know the octet rule, etc., the inert gas configuration. But what is pseudo inert gas configuration, you need to have an idea. Okay, I'll give you one example to understand this. Okay, so the point is cations with inert gas configuration are formed more easily. Keep this point in mind. Cations with inert gas configuration are formed more easily than the cations with pseudo inert gas configuration. Keep this point in mind. I'll explain you what is inert gas configuration and pseudo inert gas configuration again, so that it becomes very easy for you to remember this particular favorable condition. Okay, let us observe. See, if you consider calcium, please observe all of you, what is the element we are considering? Calcium. Okay, and whose atomic number you all know, it is 20, and whose configuration, if you write it in the orbital format, 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. This is the electronic configuration of the neutral calcium atom. Calcium being a second group element, calcium comes under the 2A group, okay, so it is an alkaline earth metal. So calcium definitely forms a dipositive cation. Yes or no? Calcium forms the dipositive cation. How it forms a dipositive cation? By losing the 2 electrons that are there in its valency shell. Okay, in the valence it is having 4s2 configuration, no? So losing those 2 electrons in the valency shell, the calcium plus 2 ion is acquiring the 3s2 3p6 configuration. Now the 3s2 3p6 configuration is becoming its valency shell configuration, isn't it? So now if you write its configuration, it is 1s2 2s2 2p6 3s2 3p6. Please observe all of you. So this is the octet configuration. Calcium soon after losing those 2 electrons is acquiring what? The octet configuration, which we call it as the inert gas configuration. What is this one? Inert gas configuration. So calcium converting itself to Ca2 plus ion, what is the configuration it is acquiring? Inert gas configuration, which is more stable. Okay, whereas if you consider the Zn2 plus ion formation, whose formation involves the pseudo inert gas configuration, okay, which is relatively less stable. Let us see that one. See, if you consider the zinc atomic number is 30. You can write its electronic configuration in the orbital format, 1s2 2s2 2p6 3s2 3p6 4s2 and 3d10. See, for sake of convenience, for better understanding, I am writing the 3d along with the 3s2 3p6 because the third shell, okay, the 3d is the third shell configuration, no? So I am placing this 3d10 alongside the 3s2 3p6 and I am writing the 4s2 after that one. No problem, okay, to understand in a better way. So this is the electronic configuration of the zinc. Okay, the zinc atom electronic configuration we have considered. Now zinc, on converting itself to Zn2 plus a dipositive ion, definitely it has to also lose how many electrons? These 2 electrons in the valency shell it has to lose. Okay, so afterwards what is happening? After losing these 2 electrons and converting to the Zn2 plus ion, the valency configuration, if you observe now, the valency configuration is the 3s2 3p6 and 3d10. Okay, this is totally a set of 2 plus 6 plus 10. How many electrons? These are 18 electrons, okay, that are going to be formed in the Zn2 plus ion. So I'll write this, okay, in this Zn2 plus configuration. So 1s2 2s2 2p6, 3s2 3p6 and 3d10. So this becomes the valency configuration now for the Zn2 plus ion, and this configuration of 18 electrons in the valency is called as the pseudo inert gas configuration. What is this configuration called? Pseudo inert gas configuration. Pseudo inert gas configuration. Okay, now listen carefully. The cations having or possessing this pseudo inert gas configuration relatively are less stable than the cations with inert gas configuration. Okay, so that means what we are saying, out of the two cations formation that we have considered, one is the calcium plus 2 ion and the other one is the Zn plus 2 ion, which cation is going to be formed easily and which cation is formed more? The Ca2 plus is formed easily than this Zn2 plus ion. Why? Because the Ca2 plus formation involves the inert gas valency configuration, whereas Zn2 plus ion formation involves the pseudo inert gas configuration, which is relatively less stable. Clear? So the ease of formation of Ca2 plus ion is greater than Zn2 plus ion. You can now tell the reason why the Ca2 plus ion is formed more easily, because the Ca2 plus ion formation involves the inert gas configuration, whereas Zn2 plus ion formation involves the pseudo inert gas configuration. So that's all, dear students. These four are the favorable conditions for the formation of cations. So please try to recollect what are those four conditions we have discussed until now. The first one is the size of the atom. Okay, larger the size of the atom, more easily the cation is going to be formed. That is our first condition. The second condition is lower the ionization energy, more easily the cation is going to be formed, right? And what is the third condition? The third condition that we have discussed is low charge on the cation. The cation with lower charge is going to be formed more easily than the cation which is having larger charge. Okay, the example we have discussed is Na plus is easily formed, then Mg2 plus, then Al3 plus. And the last favorable condition for the formation of cation that we have discussed is the pseudo inert gas configuration. The cations possessing inert gas configuration are formed very easily than the cations possessing pseudo inert gas configuration. Hope you have understand these four factors for the formation of cation, right? Now, after understanding the formation of cations, the favorable conditions for the formation of cations, let us move for the anion favorable condition, anion formation favorable conditions, which are relatively more easy and less in number. Okay, shall we start? Right. See, conditions favorable for the formation of anion. Condition favorable for the formation of anion. Okay, so in this one, for the formation of anion, the first condition is also related to the size only. Okay, low size of atom. Low size of atom. See, lower the size of the atom, more easily the anion is going to be formed. For example sake, if you consider the halogens, okay, the 7A group elements, fluorine, chlorine, bromine and iodine. Okay, these are the four group elements. As we move down the group, the atomic size increases. So fluorine is having lower size, next one chlorine, next bromine, next iodine. That means iodine is having the larger size and fluorine is having the lower size. Okay, so size order, if you consider, fluorine is lesser in size than chlorine, then bromine, then iodine. Now the point is, for the formation of anion, the atom size should be low. Lower the size, if you consider this is the size of the atom, and if you say this is the nucleus, and if you consider one more atom, if it is having this much size. Okay, so if you want to introduce an electron to the neutral atom, it is better to introduce to the atom which is having smaller size, so that the nucleus pull, if I say this is an electron, in between this nucleus and the electron, this pull will be there, no, the nucleus attraction. This is more in this first case than the nuclear pull that is present over here. Got my point? So larger the size of the atom, okay, the anion formation becomes bit difficult, whereas smaller the size of the atom, the anion is going to be formed more easily. Why? The reason is the nucleus pull is more in the cases of the atom which is having lower in size. Got my point? So basing on this particular reason, now if you observe carefully, the ease of formation will be in this order. F minus is formed more easily than Cl minus, okay, then Br minus, then I minus. Okay, why F minus is formed more easily? Because its size is smaller. Why I minus is formed with much difficulty? Because its size is larger. Simple reason. So this is our first factor. What is that one? Low size of atom. Lower the size of the atom, more easily the anion is going to be formed. This is our first factor for the formation of, favorable condition for the formation of anion. Let us move to the second factor. The second factor is high electron affinity and electron negativity values. This is also one of the important factor, dear students. Please observe, the atoms with high electron affinity and high electronegativity, both are almost relatively same, understood, but having a slight difference in calculation and in explanation and in actual existence also. These are slight different, there are differences, but the point is they explain the same thing. If an atom is having more electron affinity, you can say it can take up the electron more easily. If an atom is having a tendency to attract the shared pair, then we call it as electronegativity. So in these two things, two properties, the one thing is common, that is the atom tendency to attract the electron. So if these two values are more, you can straight away say that atom can easily convert itself into an anion. So any atom or atoms if are having higher values of electronegativity and electron affinity, definitely you can say those atoms can form the anions very, very easily. Understood? So high EA and EN values favors the formation of anion. Understood? For example, if you consider the fluorine and or you can say chlorine, I am taking chlorine and iodine. Okay, right? The electron affinity of chlorine is very high, which is in fact the highest among all the existing elements, electron affinity, remember. Okay, so chlorine, because it is having high electron affinity, than iodine, okay, then automatically the ease of formation the ease of formation of Cl minus is more than the ease of formation of I minus. Got my point? So Cl minus is formed more easily than I minus. What might be the reason? The reason is simple, that chlorine is the highest electron affinity containing element. Understood? So it can take up the electron very easily than the iodine. So chlorine can convert itself into chloride ion more easily than the iodine. This is our second factor. So those atoms which are having higher values of ionization, electron affinity and electronegativity, those are going to be converted into the anions. This is our second factor. And let us move to the last factor for the formation of the anion, that is small or lower charge, you can say lower charge. This is our third factor and the last factor for the formation of anions. And here also, in this particular anion case also, the anion that is having lower charge is going to be formed relatively more easily than the anion which is having larger charge. Okay, for example, if I take F minus, understood, and O2 minus, or else with the same element I'll explain you. Okay, see, O neutral atom, if I take O, if it has to convert into uni-negative ion, we need to add an electron. O for oxygen here, it becomes a uni-negative oxygen ion. And at the same time, to this uni-negative oxygen ion, if I add one more electron, then what happens? It becomes O2 minus. Got my point? So now what I want to say is, the ease of formation of O minus is more than the ease of formation of O2 minus. Why? Because it is very easy to accommodate one electron, one external electron, understood, than more than one. If what happens if you add more than one? If you add more than one, automatically the internal electronic repulsions, the newly that are going to be developed between these newly coming electrons and the already existing electrons would decrease the stability of that particular ion. So in order to form such kind of ion, definitely we need to spend more amount of energy. So basing on that factor, it becomes very difficult to form such kind of ions. Got my point? So remember this very simply. So what is that one? Higher the charge on the anion, that anion is going to be formed with difficulty, whereas the lower charged anion, that is going to be formed very easily. That means you can say now ease of formation of O minus is always higher than O2 minus. Why? O2 minus formation requires the addition of 2 electrons, whereas O minus formation requires only addition of 1 electron. Understood? It is always easy to add 1 electron than 2 or more electrons, isn't it? So what is the third factor for the formation of anion? Favorable condition for the formation of anion? Lower charge. Got my point, dear students? So for the formation of anion, what are the 3 favorable conditions that we have discussed until now? One is smaller atomic size. The atoms with smaller atomic sizes forms the anions very, very easily. And what is the second condition? Higher values of electronegativity and electron affinity. Those atoms which are possessing higher electronegativity and higher electron affinity values definitely tend to convert themselves into anions very, very easily. Okay, that is our second factor. And what's the last factor for the formation of anion? Lower charge on the anion. Okay, the anion with lower charge is going to be formed easily than the anion with higher or larger charge. So these are the 3 favorable conditions for the formation of anion. And we have already discussed 4 favorable conditions for the formation of cation. Now dear students, please observe the point. These 4 conditions for the formation of cation and 3 conditions for the formation of anion automatically would become the favorable conditions for the formation of ionic bonding or ionic compounds. Got my point? So these total 7 factors are the favorable factors or the favorable conditions for the formation of ionic bond. Okay? So all of you please try to understand these 7 factors which we discussed until now, which are relatively very easy. Try to memorize these things. Okay? Keep all these 7 points in your mind so that you can solve the questions like the stability orders, ease of formation, okay, etc., or more ionic, less ionic characters, etc. Such questions you can answer very easily. Got my point? So this is the total 7 factors, okay, which are the favorable factors for the formation of ionic compounds or ionic bonds. I hope all are able to understand these 7 factors, and these factors, you will keep these 7 factors into practice. Okay, try to practice them. In very short period we are going to solve our work sessions. That means worksheet 1 we are going to start very quickly. We are going to move towards this worksheet solution. Okay, after worksheet 1 I'll explain you few more theory concepts, then we move to the worksheet 2, similarly worksheet 3. After finishing these 3 sheets, you can say the chemical bonding topic is going to be completed. So till now we came up to this ionic bond and ionic bond favorable conditions, and in the next video I'll explain you the properties of ionic compounds. Okay, after finishing those properties of ionic compounds, we will move for this worksheet 1. Okay, we solve all the questions that are there in our material. Okay, in worksheet 1 I will explain you each and every question so that it becomes very easy to solve them. Okay, so hope this video you will find it very interesting and it help you in understanding the factors favorable for the formation of ionic compounds. Okay, thank you so much. Okay, keep learning chemistry more, which is very useful in your entrance exam preparations and in your future endeavors. So chemistry is a very important subject, very interesting subject. If you learn this with passion, definitely you can create wonders. Thanks for watching and thank you so much.